All right, our final example. And the difference with this one is, of course, the theta is now going or approaching pi instead of 0. Now, all our identities are theta going to 0, so we really don't want to deal with this particular situation. So what we can do here, and we can make a bit of a switch or a shift. So what we say is that theta is equal to pi plus h. All right. Why do we do that? Well, we still have theta approaching pi, not what I wanted to do. All right, so theta approaching pi. I still have theta equal to pi, but what we're going to do is we're going to make a shift and say, let's look at the limit as h approaches 0. Okay, so we've made this shift and said, okay, yeah, I'm interested when theta is equal to pi, so there's my theta equals pi, plus a little bit, plus h, and we're going to look at what happens when h goes to 0. So now, anywhere there was a theta, I have to replace it with pi plus h. So I have to do this substitution as well. All right, so now we're analyzing a function where h is going to 0. Cos of bracket pi plus h, all divided by 2 sine bracket pi plus h. Now at this point you're saying this is going to be really hard because look at all the stuff that's inside that angle. Au contraire, mon frère. If you pull out that excuse me, trig identities sheet, we are looking at our addition and subtraction formulas. So down in the bottom left corner, 1 plus, what is the equivalent of cos pi plus h? Sorry, not addition and subtraction, we want correlated angles. Sorry, related angles. Even up higher. I'm looking at the wrong part of my sheet. My brain's doing the right thing. So related angles. So we're looking for cos of pi plus an angle. And you'll find it in the second column. It's cos of pi plus a. This really becomes negative cos of h over 2 times, using your related angles. Now you're looking for sine of pi plus h, that's just straight above. It would be negative sine of h. So we'll clean this up before I do any more work. So there's 2 major steps with this question. So 1 minus cos of h over negative 2 sine h. So there's two major steps here. Here's step number 1. You have to always, or you always want something approaching 0, and that's what we did. Step number 2 is use your identities. And I mean all identities are in play. Okay? Everything you did last semester in advanced functions is on the table here. So you need to use all those identities that you talked about. That being said, now we're down to analyzing this specific problem. First of all, do we have a problem? If theta is 0, what happens to the denominator? It's going to equal 0. So, can't factor because there's no squares. Rationalizing or multiplying by conjugate, we could try that. So I'm going to multiply by 1 plus cos h, top and bottom. So our numerator is a difference of squares. So the first one squared is 1, and it'll be minus cos squared h. And on the bottom, we have negative 2 sine h multiplied by this mess, 1 plus cos of h. Now we need to simplify that top, and people are probably starting to see where we're going with this. We're going to use another trig identity to clean that one up. So whether you replace the 1 with sine squared plus cos squared h minus the cos squared h that we originally had over negative 2 sine h, 1 plus cos h. Those two will cancel each other out for us. And now I have the top with a sine squared h, and the bottom is being multiplied by sine h, so they will reduce my exponent. So the limit as h approaches 0, all we have left on top is a sine h On the bottom, I have negative 2, 1 plus cos h. When I make that substitution, do I have a problem anymore? So when I'm looking at that denominator, the answer is no, because I'm going to have 1 plus 1 in there. Cos of 0 is 1. So I have negative 4 in the bottom, but on top it ends up being 0 anyway. So the answer to this question is 0. All that work for an answer of 0. Homework's posted here. Okay. There will be a handout. If you want extra questions, you can obviously do the even ones as well. The trig ones, again, they take practice. You're not going to be able to look at one or two and say, I know how to do them all. So please make sure you use your time effectively and get through and try each and every one.